Now, let's talk about the systems we can use to protect ourselves against the hazards of falls. Guardrails should always be considered the first defense against falls. Let's see how guardrails can be installed safely and the design requirements of those systems. It's important to remember that not only is your personal safety at stake, but if the rails are to be left in place, so is the safety of all the trades that follow you. Another consideration is the fact that once another contractor takes responsibility for maintaining those rails, you could be exposed to a fall if they haven't maintained them properly. So you need to keep your eyes open during all phases of the work. Guardrails should be placed around all unprotected sides once access to the edge is no longer needed. Once the metal deck has been installed on a given floor, a guardrail should be put in place around the entire perimeter. In addition, a guardrail system should be placed around all unprotected sides of any openings, including elevator shafts and stairwells. This means the guardrails may need to be installed prior to deck installation, so those openings are protected while the deck is being installed if this is the only means of fall protection. Wire rope guardrail systems can usually be installed at the perimeter of structures running from column to column. Even though the new standard recommends punched holes in the column web, you may still be working with erection nuts or washers tacked to the column. If this is the case, you need to be careful when you install the cables to avoid abrasion and sharp edges. The top line of rope should be installed between 45 and 42 inches from the finished floor. It should be pulled tight using a cable dog and come along. Install the required number of wire rope clips for the diameter of rope being used. Then install turnbuckles to maintain the lines and prevent excessive deflection or sag. It may be a good idea to install stoppers at columns to help prevent sag. A fist grip clamp works well and is easy to use. Once the top rail is fully installed, it must not deflect over 3 inches when 200 pounds of force is applied in a downward or outward direction. After repeated tightening and the deflection still exceeds 3 inches, you need to install intermediate posts and test again. The top rail of guardrail systems may be constructed of wood, steel pipe, or angle, manila, synthetic, or wire rope. Never use plastic or steel banding. Remember, regardless of which material is used, the top guardrail must be able to withstand a force of 200 pounds in an outward or downward direction. Continually test the tension throughout the project to make sure the guardrails hold up to these standards. Finally, guardrail heights may need to be increased if worker heights are increased. Now, this happens through the use of stilts, ladders, scaffolds, or some other work platform where fall protection is not integrated into the system. Like the top rail, the middle part of the system can be made from many different materials. Typical designs include a wire rope mid-rail, screen, or mesh. The mid-rail should be halfway between the top rail and the walking or working area. All mid-rails, including screens or mesh, must be able to withstand a force of 150 pounds in an outward or downward direction. They also must meet the 3-inch deflection rule. If excessive deflection remains a problem, it may be necessary to install intermediate vertical members. These serve to provide additional support and fall protection or falling object protection. If screens or mesh are used, they should extend the entire distance from the top rail to the walking or working level, or at least to a level adequate to keep all materials and tools on the deck. In addition, screens or mesh should continue along the entire opening between the top rail supports. Toe boards are not typically installed as part of the steel erection process, but if they are, they must be at least 3.5 inches high, have no more than a 1/4 inch gap below or 1 inch gap between boards, and they should withstand a force of at least 50 pounds. Now, the guardrail system should be checked at least once a week. You need to make sure that the tension hasn't decreased. Remember the 3-inch deflection rule. Also inspect all the cables and clamps. Sometimes workers borrow clamps or they work loose. A loose or defective system cannot protect you if you happen to fall. It's important to remember that no matter how well your guardrail system is designed, objects and tools can easily fall to lower levels. Always make an attempt to minimize this possibility by keeping bolts in tied-off buckets. Also, always use caution when using hand tools so as not to drop them, and never leave tools or equipment loose on the steel. You should also make sure that the entire guardrail system is safe from puncturing and lacerating employees. No one should be able to snag clothing or equipment. This may mean whipping the ends of cables with tape to make a smoother transition. Now, this is very important. Be sure that when you install cable clamps for termination, you never saddle a dead horse, and that you soften turns or use a thimble to prevent abrasion. Fist grip clamps can make this a foolproof installation. If you're working in a hoisting area, you should be rigged so that you may only move to the edge of the walking or working surface. When a guardrail system is used in a hoisting area, a chain, gate, or some type of removable guardrail must be placed across the access opening when hoisting is not taking place. Make sure that this installation is easy to use and, if possible, self-closing to help prevent accidents. Finally, it's important to remember that guardrails are not necessarily anchorage points. You should never tie off to a guardrail or to any horizontal cable unless you're sure that it's been designed to withstand the impact forces generated in a fall. As a suggestion, you could use special color flags to indicate that a guardrail is safe for tying off. If you have any questions, ask your supervisor. Safety nets are a type of fall protection that may be used to catch falling workers on any job once enough structure has been erected. The downside of these systems is that they only work after you've already fallen, so it's critical that they be installed and used properly. The nets must be installed as close as possible under the working or walking area. However, they can never be more than 30 feet below. When nets are used, the potential fall area must be unobstructed. A net won't do you much good if it's set just above a beam that could break your back in a fall. There are specific rules that cover how far a net must extend beyond the outermost portion of the working or walking area. The distance is determined by how close the net is to the working or walking area. If the net is up to 5 feet below, the net must extend 8 feet beyond the outermost portion. If the net is between over 5 and up to 10 feet below, the net must extend 10 feet beyond. And if the net is more than 10 to 30 feet below, it must extend 13 feet beyond the outermost portion of the working or walking area. Remember, 30 feet below the walking or working level is the maximum distance allowed. These gradually increasing distances from the building or surface face help protect you from the forward momentum that can be generated in a fall. Each time you install a safety net, it should be tested before it's actually used as a fall protection system. It should also be tested if it's relocated after a major repair or at 6-month intervals if it's left in one place. If it's physically possible to test the net, you should follow these guidelines. Drop a 400-pound bag of sand that has a 30-inch diameter from the highest point a worker may be exposed to from the fall hazard. Then check the net to make sure it withstood the impact without breaking. Finally, make sure the net has sufficient clearance so that it doesn't come into contact with any other surfaces or structures below when the impact occurs. Remember, if you land in the net and strike a member, you could be seriously injured or killed. Now, sometimes the employer may demonstrate that it's unreasonable to perform the drop test. In this case, a competent person will sign a certificate asserting that the safety net could stand up to the drop test. That record is available at the job site. Regardless of whether the net is proof tested or not, it's imperative that it be thoroughly inspected. The requirements for the construction of safety nets are very specific. The maximum size of the mesh opening cannot exceed 36 square inches, nor be longer than 6 inches on any side. In addition, all mesh crossings must be secured to prevent enlargement of the opening in a fall. Each net must have a border rope for webbing with a minimum breaking strength of 5,000 pounds. Finally, the connections between safety net panels must be as strong as the integral net components and be spaced not more than 6 inches apart. Safety nets must be inspected at least once a week. Look for wear, damage, or any deterioration of any kind. Always inspect the safety net after any incident that could affect the integrity of the net. If any materials, tools, or scraps fall into the safety net, they must be removed as soon as possible, certainly before the next work shift. Many times, steel erectors are exposed to falls before enough structure has been erected to install guardrails or nets. The personal fall arrest system is designed to minimize injury in a fall from a working level, or when used as a fall restraint to prevent workers from falling. The system is engineered to help protect you in a fall, but it's important to remember that your body may be subjected to a great deal of force if you fall. If worn improperly or if used incorrectly, these systems can either fail or cause injury to you. Always be sure to read and follow the manufacturer's guidelines for the equipment you use. Remember, it could be the only connection that prevents you from hitting a surface below you after you've fallen. The system consists of a full body harness, an anchorage and connectors such as a lanyard, deceleration device, Lifeline, or a combination of these. All the rope, straps, or webbing in this system must be made of synthetic fibers. Note, the use of a body belt for fall arrest was prohibited as of January 1, 1998. Body belts may, however, be used for a positioning device system, which we'll cover later. An anchorage is used for the attachment of your personal fall protection system to the structure. It can't be used for any other support, such as for a scaffold or suspended platform. Typical anchorages used in steel erection can be beamers, cross-arm straps, chokers, or beam posts and horizontal lines. The anchorage must be capable of supporting at least 5,000 pounds for each employee attached. Or it could be designed, installed, and used under the supervision of a qualified person. In this case, the personal fall protection system must maintain a safety factor of at least 2. The hardware part of the system must meet some pretty serious safety requirements. The connectors must be drop forged, pressed, or formed steel, or made of equivalent materials. They also must have a corrosion-resistant finish with smooth surfaces and edges to prevent damage to other parts of the system. The D-rings and snap hooks must have a minimum breaking strength of 5,000 pounds. In addition, all snap hooks in a personal fall protection system must be of the locking type. This prevents them from accidentally opening in the event of a fall. Between the D-ring on your harness and the anchorage point is some type of lead or connection, either a lanyard or a lifeline. We'll look at lifelines in a moment. Retractable lanyards automatically limit free fall distance to 2 feet or less and must have a minimum breaking strength of 3,000 pounds. These types of devices minimize impact forces transmitted to your body by minimizing fall distances. However, if you're using a retractable lanyard along an open-sided floor, your horizontal movement could extend the retractable enough so that if you fell, you could pendulum down into a lower floor. Keep your anchorage point well above and behind you to help prevent this. Of course, no part of a personal fall protection system should ever be used for hoisting. Other types of devices will allow a fall distance greater than 2 feet. In this case, rip-stitch lanyards and tearing or deforming lanyards must have a minimum breaking strength of 5,000 pounds. However, these systems must limit the free fall to 6 feet or less. In addition, the ironworker must not impact a lower level. The system must also limit the arresting force on an ironworker to 1,800 pounds and bring him or her to a complete stop with a maximum deceleration distance of 3.5 feet. The reason for deceleration in a fall is to minimize the pressures exerted on your body when it comes to a stop.
A sudden stop could be like hitting a concrete wall, but a decelerated stop could be more like hitting a drywall barrier. Still a quick stop, but cushioned somewhat. So it should be clear that the less distance you actually fall, the less force is created.
The best way to minimize your fall distance is to tie off above you wherever possible, or keeping your anchorage point as close to your D-ring as possible.
Tying off above you isn't always possible, but can usually be done with pre-planning, using beam posts or some other type of overhead system. Now, where beam posts can't be used, other methods of protection are available.
This could mean shortening your lanyard and cooning the beam if you're using a beamer. If you need to use a choker for an anchorage point, make sure that it's engineered for the fall impact and that it's as short as possible.
If it's too long, you could end up hitting the floor or ground below.
You may actually have to use a different type of lanyard when tying off below you. You see, some lanyards are specifically designed for increased impact forces. They typically use a longer deceleration device, so you'll actually fall farther before you stop.
Talk this all over with your supervisor before you go to work. Planning ahead can get you the right equipment and home safely at the end of the day. Lifelines form a link between your lanyard and a suitable anchorage. Because the lanyard is able to move along the lifeline, you're able to travel freely in a defined work area. With this additional mobility comes several additional concerns. Lifelines use wire rope or synthetic lines to form either a horizontal or a vertical system. Each has its own design features and requirements. All lifelines must be designed, installed, and used under the supervision of a qualified person.
As before, this part of the personal fall protection system must maintain a safety factor of at least 2. In addition, the wire rope or synthetic line must have a minimum breaking strength of 5,000 pounds. Horizontal lifelines may be attached along the deck or above the working walking surface between columns. These design systems should take into account the distance between posts, the strength of the wire rope and anchorage point, and the method used to minimize impact forces on the line. It's not always easy to tell the difference between a guardrail and a horizontal lifeline.
Remember how guardrails were pulled tight using a come-along? Well, many horizontal lifelines have built-in sag.
In the case of a fall, the sag reduces the force of the impact on both you and the system. This helps protect both. However, installed improperly, a horizontal line used as an anchorage point could pull a column or post over, allowing you to fall.
Remember, guardrails are not lifelines. They will not support you in a fall.
You should use a colored tape to indicate that a cable is indeed a lifeline suitable for tying off. Sometimes horizontal lifelines are taut. In this case, a shock absorber connects the wire rope to columns or posts. This device helps absorb the impact of the fall. This is similar to your deceleration lanyard.
Be sure to check with your supervisor before attaching to any horizontal line if you're not sure of its stability or type.
Vertical lifelines allow access to locations that are difficult to reach or would take a long time to set up an alternative method such as a scaffold. Just like horizontal lifelines, a suitable anchorage, harness, and connector must be used. In addition, a one-way locking device must be used to attach the ironworker to the lifeline.
Also, if vertical lifelines are used, each ironworker should be attached to a separate lifeline.
Multi-level suspended scaffolds or similar work platforms often use horizontal lifelines. These are most common when doing siding or fascia work. In the case of support failure, these horizontal lifelines may become vertical lifelines. Therefore, the ironworker must use an attachment device that locks in both directions on the lifeline. During the construction of an elevator shaft, two ironworkers may be attached to the same lifeline in the hoist way. They must be working on the top of a false car or platform that is equipped with guardrails, and the lifeline must have a minimum breaking strength of 10,000 pounds. It's also important that all lifelines be protected against being cut or scraped. When running over sharp edges, you could use a garden hose or fire hose to protect the line. It's recommended that you never attach a vertical lifeline to a horizontal line. The impact of a fall can stretch each line excessively, possibly allowing you to hit the ground or a lower level. Because these systems are designed to stop you after you've fallen, you'll have to be able to get down. Rescue procedures should be addressed in the site-specific plan and discussed on-site. All of the stated personal fall protection system weights are based on a combined ironworker and tool weight of less than 310 pounds. If this limit is exceeded, you should contact the equipment manufacturer before making any modifications or exceeding this 310-pound limit. Each ironworker should inspect their personal fall protection system each day. If any part is questionable, it should be replaced before using. In the event of a fall where any part of the system is subjected to impact loading, it must be immediately removed from service. It cannot be used again until a competent person has determined it to be undamaged and suitable for use. Many manufacturers will take these systems back and either recertify or replace them. A positioning device system is a body harness or body belt rigged so that an ironworker can work on a vertical surface, like a wall or column, with both hands free. The same requirements for personal fall arrest safety hardware, lifelines, anchorage, use, and inspection apply equally to positioning device systems. The positioning devices must be rigged so that an ironworker cannot fall more than 2 feet. With a body harness, the most common approach to positioning is the use of side D-rings. These are mounted at the hip area of the harness. This allows you to tie off to the work in front of you. Remember, though, that a fall protection system must still be provided when using a positioning device. So you'll still have a lanyard or lifeline attached to your back D-ring as well. Thank you for watching this video. Your family will thank you for coming home safely every day.